video is about reaction quotient. Reaction quotient is the letter Q. So far you should have been exposed to your equilibrium constant of K. This is the ratio at equilibrium. So you're looking at your products divided by your reactants at equilibrium. That's the major difference here, is that with this KEQ, that number can sort of tell you at equilibrium, do you have more products or more reactants based on the number. How Q is different, Q, the reaction quotient here, reaction quotient. This is when you can actually look at the reaction at any point, that's your reaction quotient, and see if the reaction is going to continue moving forward to get more products or moving backwards to get more reactants. And this is going to look at your reaction quotient comparing to your Q. So basically, once you get your reaction quotient, you're going to compare if the Q is going to be the same as K, your equilibrium constant, is your Q less than K, or if your Q is greater than K. Okay, how you set up your reaction quotient or how you calculate your reaction quotient is exactly identical with your equilibrium constant. You have your products and you have your reactants, and you're finding the ratio between the concentration of your products and the reactants. So let's make sense out of this. What happens when Q is equal to K? Remember, the reaction quotient is at any time of the reaction. So if the quotient is equal to K, the equilibrium constant, then that means that it is at equilibrium. That means that the only way you can get this equaling to K, which is exactly the same, is pretty much when it's at equilibrium. Oh, I should put this in a big letter, A, and then B, and B, right? So in order for Q to equal to K, basically the products and the reactants have to be the same. If it's at the same at equilibrium, if it's the same at the reaction quotient, then they must be at equilibrium. So that means at that point of the reaction, it is at equilibrium. So what happens when the Q is less than K? So first off, you have to understand how do you get Q to be smaller than K? So K, again, this is your products over reactants, and your Q is exactly the same thing. So this is also your products over reactants. But then now, how do you get this Q that is smaller than K? Well, if it is smaller than K, that means that your reactants is going to be larger. That means at that particular point in time of your reaction, you have more reactants. So at that particular time, since you have more reactants, that means that it's going to continue going to make more products. So this is something that's sort of conceptual. So you have to make more products. So just to recap, how do you get Q to be smaller than K? Well, in order for Q to be smaller than K, your reactants have to be larger. And your concentration is large, so that means that you can still make a lot more products to get into K, which is your equilibrium. What happens when your Q is greater than K then? So if we were to scroll down here, Q is greater than K. How do we get that? Again, if you look at this, Q is your products over reactants. Let's try to make sense out of this. K is also products over reactants. But now, because they're not the same, Q is actually greater than K. Well, how do you get that? Well, in order for Q to be bigger than K, your products have to be bigger. And if you have a bigger or larger amounts of products, that means the reaction have made a lot of products, and it needs to go back into the reverse reaction to go back in making more reactants. So this one, you have large number of products, so the reaction is actually going to go backwards, so go backwards to make more reactants. That's what that means when Q is greater than K. So when you have this, don't try to memorize what's going on, but try to, if you were to sort of write this down and break it down and ask yourself, well, logically, how do you get Q to be smaller than K? Well, the only way to get Q smaller than K is when the reactant is a large number. If it's a large number, that means you have high concentration. And if you have a high concentration of reactants, then you need to make more products. On the other scenario, when Q is greater than K, that means you have more products. If you have a lot of products, that means it has to go backwards to make more reactants. So whenever you ask a reaction quotient question, remember that is at any point in time. It's not at equilibrium, it's at that specific point in time. And once you have calculated your Q, you're going to compare that Q value with the K to see, is your reaction going to continue moving forward, or is it going to go backwards, or if it is at equilibrium. So that's the meaning or the purpose of the reaction quotient. Hopefully this video has helped you, and try some practice question to help you along the way. So see you next time.